Hi, my name is Yuri Yudin. I'm VP of Engineering at GridGain, and today we're going to talk about GridGain 9 and analytics. So first, let's look at what we're going to cover today. We will start with the introduction of GridGain 9, what it brings on top of the third version of Ignite. We will then look at the secondary storage concept and how it works. With that introduced, we will go into the details of the columnar store and discuss its benefits. We'll then see how to configure and use secondary storages. And last but not least, then try it all hands-on in a small demo. So let's get into it. So GridGain 9, as Stan already mentioned in his talk, GridGain 9 is built on and extends Ignite 3. It is based on the same code and leverages all the good capabilities and architectural changes Ignite 3 brings, like rough consensus-based core, serializable transactions in VCC, dynamic configuration, and improved user experience. On top of that, GridGain adds a number of features and improvements, making Ignite enterprise usage ready. These are the things like transactional data import and export, various integrations, improved security capabilities, enhanced availability, like snapshots with point-in-time recovery, rolling upgrades, data center replication, and many more. It also improves scalability and performance with fine-tuning, different distribution algorithms, and support for the secondary storage. The latter, as I mentioned, is the focus of our today's presentation. So coming to it now. So secondary storage. As Ivan mentioned in his talk earlier today, Ignite 3 adds new capabilities in terms of the data storage. There are more than one storage engine available in Ignite 3. You probably remember a few of them, like Persist and IMM, which is pure memory. Those two are the main ones. There is also RocksDB, which is currently experimental. And all of those are configured via distribution zones with the storage profiles, which in turn may include one or more storage engines. They are subsequently used to create tables using specific and potentially different distribution zones and hence storage profiles. What GridGain adds here is the concept of a secondary storage. With the secondary storage enabled, the table is created with two zones. One of them is called primary, and is used for all your transactional load as usual, and a secondary. The data arriving at the primary zone is asynchronously copied into the secondary zone, which is in turn backed up by the secondary storage engine, in our case, columnar. We are leveraging the RAT-based core of the Ignite 3 here, extending and adding new replication mechanisms. And with the concept of distribution zones, one can both collocate and segregate primary and secondary zones on the same or different nodes. We do recommend segregation because you probably don't want your heavy analytical queries to impact your transactional load on the cluster, but if you really want to do that, you can as well. Here again, we leverage the benefits of Apache Ignite 3 and Apache Calcite-based SQL engine, which is clever enough to decide which storage engine to use for a particular query or part of the query. We also provide custom hints to force the SQL engine to use a specific storage engine if needed. Overall, the secondary storage is not a completely novel concept. There are other implementations. They are also leveraging Raft as the basis for such internal replication between the engines. Excuse me. However, what GridGain does differently here is potentially supporting more than just one type of the secondary storage, and in a very flexible way. Today it is the columnar store that we support, but in the future, one can imagine all kinds of different secondary storages fine-tuned for the specific use case. We are also adding support for storing more data in the secondary storage than on the primary. Here, well, for example, primary zone might have an expiration policy, which will delete the data after a certain time. but that data would not be deleted and would be retained on the secondary for the future use. So now let's see how the columnar store works and what it is. As the name already hints, it is using the different format for the data than our standard key value store. And it is columnar. So we also base it on the industry standard and open source Apache Parquet implementation, leveraging all the benefits this format brings. It's efficient data compression and encoding algorithms, predicate pushdowns, embedded metadata, column level statistics, support for complex and nested data structures out of the box. And last but not least, since it's an open format and widely used across the ecosystem, it actually introduced the good level of interoperability between GridGain and other systems as well. We also use Apache Arrow library as the basis here, which brings additional benefits in terms of performance, like vectorized execution and also compatibility across the ecosystem. To ensure the new and changed data is processed fast enough, we use internal in-memory and on-disk structures to accumulate the fast changes. And as usual, the regular housekeeping is done to merge such changes into the underlying Apache Parquet format. With the capable calcite SQL engine, all of the above brings a significant performance improvements for your heavy analytical queries. Segregation of the load with primary and secondary zones allocated on different nodes brings further benefits of eliminating the noisy neighbor problem. And also, all of the above opens the door for future enhancements and capabilities, like on-the-fly Apache Iceberg support. We could also extend the storage capacity into the cloud and add more advanced lakehouse integrations and many more. Now let's have a look how one can use it. So, well, read the documentation is the first suggestion, but who actually does that? So let's get into it. The first step in configuring the columnar store is to add respective profile into the Ignite storage configuration. You should do this on each of the nodes, which are going to be used for analytics, but in fact, you can do this on all nodes as well. And this could easily be done via Ignite's new and shiny command line interface. So I'm showing here how to do that, but we will have a look at this a little bit later in the talk on during the demo. Essentially, this new section adds a storage profile called columnar, which is using the columnar engine. Note that while you can give the profile a different name if you prefer, the engine name is hard-coded and should remain columnar. One thing to note here is that node configuration in Ignite 3 and GridGain 9 is only updated on the node startup as of now. So you would need to restart GridGain 9 on each of your nodes after you updated the node configuration. You don't need to do that with the cluster configuration, so don't get this mixed up. Again, another way that you can modify this configuration is to just go and do that on the file system itself. Depending on how you install GridGain 9, it could either be in etc GridGain 9 or in another location. Or you also can use your favorite automation software, whatever you prefer, to update it on all respective nodes, and then you can restart it. All right, that's the first step. Then you would obviously need to create a couple zones, one for the primary key store and another for the columnar. Again, I'm showing the interactive mode of Ignite command line interface here, and it's easy to use, and there's syntax highlighting and stuff like this. Again, we will look at this during the demo. So here, one zone contains the default profile, and another one your columnar one. So again, make sure to use the profile name, not the engine name. As soon as you have those defined, you're all set to create a table. The syntax here is relatively straightforward. You're providing the primary zone name, and then the secondary zone. You're also passing the specific profile for the secondary storage here. Again, don't mix up and use just profile name, not the storage name here. Well, what I'm using, well, since in my case they are the same, so it's easy to guess. So now you can add data into your table. You can add the data as you would normally do. It doesn't have to be through SQL. You can use all the interfaces that Ignite 3 and GridGain 9 provides. Well, I'm providing an example of insert, but it could be anything. And as soon as you do that, as soon as the data is there, it is automatically replicating to the secondary store, and you can then query it. If you want, you can instruct the SQL engine to use the columnar regardless of the cost model. And for that, you're running it passing the use secondary storage hint, as you can see in the command here. And yeah, now let's have a look at it into the real command line interface, and let's get into the demo. So I would need to reshare my screen and get to it. All right. So already done a few preparations, obviously, but let's have a look. So first of all, I have a 6 nodes cluster, which is brought up as LXC containers on my server in lab. I already updated the storage configuration on all of the nodes, so let's just check them. So node config show Ignite storage. So that's on the local host. So as you can see, I have this engine columnar and name columnar in the profile. One can also use different URLs here. So for example, if I want to have a look at the configuration on the node number 4, I can pass the URL here and run the command like this. The configuration here is pretty much the same. I copied it across all of the nodes. And again, in order to segregate, you don't have to set the profile on just those nodes which you will use the columnar store. You can set this everywhere. It's just the zones and the configuration of the create table and the table configuration would judge how the data is stored and how it's replicated to the secondary store. So now let's get into the interactive mode of the command line. So let's check if the cluster is actually alive, cluster status. And you've seen it actually offers me a few suggestions from the command history. We can also look at the cluster topology. As you can see, I have like 6 nodes here. Now let's go into SQL and create a few zones. So zone 1 with the default, zone 2 with the columnar profile. And now I can create a table. So as you can see, I'm passing the zone 1 as the primary zone and zone 2 as the secondary, which will be my columnar store. And the secondary storage profile would be columnar. Again, the multiple storage profiles in the zone, so I would need to specify which one to use. Okay, so created a table, and now let's insert the data into it. Right, so from people, Right. So selecting from the primary store first, and then using the hint, selecting from the secondary. Right. So as you can see, the data is in both of them. Okay, then let's have a look. We can also have a look at the system zones table to see that we created those zones. And as you can see, I've got a couple more zones here called default zone and columnar zone. I use that to populate the data with the well-known TPCDS benchmark. We can also see it into the system tables that I've got all of those tables for the TPCDS created. And I also passed, I also filled them with the data generated for with the 10 gigabytes scale. This is a relatively small cluster, so for the sake of the demo, we don't want the really large environments, and because that's going to take some significant amount of time. But let's still run a few queries to just demonstrate that benefit is there. So I have like query 03 SQL here. So that's the standard query from the TPCDS, the third one. And I have it modified for the columnar, passing the secondary storage here, just to make sure that the secondary storage is forced and used. So let's have a look how it all executes on the cluster. So first, running the query without the columnar, using the KV. Again, the data set is relatively small, but the cluster is not as fast as well. It's not the proper cluster. It's the cluster brought up as the containers, set of containers on one machine. So as you can imagine, it's not as fast, but still for the 10 gigabytes, it's reasonably good. Should be able to wait until it finishes. It should take like around 40 seconds, I think. So while doing that, yeah, it's now finished. Oh, sorry, I forgot to pass the timing here. Let's do that again. So passing the time and measuring the time it took to execute the query. Sorry for that. Again, it's going to take another 40 seconds. Anyway, so let's wait a little bit. And while we are waiting, so as you can see, yeah, 41 seconds. And now let's run this with the columnar. Okay, that's going to be faster, at least a couple times faster. And yeah, again, this is the very weak system. It's not optimized for the large load, so we don't expect a real performance here. But and the data set is relatively small, so the difference between the columnar and the DKV is not that significant. Yeah, but it's still there. So as you can see, it executed in 28 seconds. So fast enough. Already significantly faster, than without the columnar. Okay, that's it. Thank you very much for listening and watching, and see you later.